Okay, on today's video, we're going to be talking about some different types of angle relationships, some different ways that angles can be related. We're going to start out by doing this graphic organizer for the different types of angle relationships. So the first type of angle relationship is called adjacent angles. The word adjacent simply means next to. So adjacent angles are just simply two angles that are next to each other. By definition, it says two angles that are next to each other and they share a common side. So let's draw an example of what some adjacent angles would look like. Here you see one angle, and if I were to just take and just somewhere in the middle split that, these two angles, angle 1 and angle 2 here, would be adjacent angles. Next up, a special type of adjacent angle, complementary angles, we're going to draw. And two angles are complementary if they add up, they have a total of 90 degrees. So I'm trying to draw here what a 90-degree angle would look like. A 90-degree angle, we know, is what's referred to as a right angle. So I'm going to put me a box in here. This is a right angle. And complementary angles is any two angles that add up to 90 or have a sum of 90. So if I took and I split this, these two angles, since if you were to take this angle and put it together with a measure of this one, maybe this one has an angle measure of something like 30 degrees and this one has an angle measure of something like 60. Those two angles would add up to 90 degrees. So, and you can see that pictorially that those two angles, if you put them together, have a 90-degree measure. Another type of angle relationship here is called supplementary angles. And any two angles that add up to 180, who has measures that add up to 180. And we understand that if 90 is a right angle, if you put two 90s, that would be a straight line. This is what 180 looks like. That's a 180-degree angle. So if I were to take and somewhere in the middle here, just split that. These two angles here, since their sums form a straight line or 180 degrees, those two angles would be supplementary. Now these have another special name. We call them a linear pair. And notice by definition it says a linear pair is two angles that are adjacent and supplementary. So they have to be adjacent, which means they have to be next to each other, sharing a common side, which is actually the exact same drawing that I just made. These two angles are adjacent because they share this common side in the middle. They're next to each other, and they are supplementary, which means they form a straight line. These two angles, angle 1 and angle 2, form what we call a linear pair. Notice the root word of linear is line. They're a pair of angles that form a line. And then the last type of angles that we're going to look at, two angles across from each other on intersecting lines. If you ever have two lines intersecting, and they have to be straight lines, two lines that are intersect at some common point in the middle, and let's call these angles 1, angle 2, angle 3, and angle 4. The angles that are across from each other, notice that 1 and 3 here are across from each other, and angles 2 and 4 are across from each other. Those are called vertical angles. And notice what it says, vertical angles are always congruent or the same size. So here, angle 2 would be congruent to its vertical angle would be angle 4. Because again, straight lines, the angles across from each other. Angle 1 in this case would also be congruent to angle 3 because they are also vertical. Now I want to point out something else here, that since you have a straight line, I want you to notice that angles 1 and angle 2 here, from what we just talked about in the previous example, angle 1 and angle 2 would actually they would form a linear pair. Angle 1 and angle 4, because you have this straight line, would form a linear pair, and so on and so forth. Okay, now identifying types of angles. Let's look at these different types of angles and say, okay, check all the relationships between angle 1 and angle 2. Anytime, again, you have intersecting lines, the angles across from each other will always be vertical angles. Number 2, if this is a 90-degree angle, which means this on the other side is 90, angle 1 and angle 2 make up that 90-degree angle, so that means they would have to be complementary. adds up to 90. Now here, be careful because angle 1 and angle 2 are not vertical here. Angle 1 and angle 2, you could actually get rid of this line here. You've got a straight line, and angle 1 and angle 2 make up that straight line. That means that they would be a linear pair. And if you want to get technical about it, they would be supplementary, and they're also adjacent. And I didn't think about it, but on the previous example, angles 1 and 2 there would also be adjacent angles. Here, angles 1 and 2, we don't know if they add up to 90. We don't see a box here that says it's a 90 degree, so all we can say there is they're next to each other. They're adjacent. On the next one, notice that angle 1 and 2 are created by these two straight lines. That other line really has nothing to do with it. We could actually get rid of that. So angle 1 and angle 2 would be vertical angles, as well as angle 1 and angle 2. And the next one, they would also be vertical angles. Now, this next one's a little bit of a challenge problem because I want to point out that since this is a right angle, that would force this to be a right angle as well, because those two have to add up to 180. This would also be a right angle, and this would be a right angle. These two lines are perpendicular to each other. So since angle 1 is a right angle, means it's a 90-degree angle. Angle 2 is also a 90-degree angle. Those two angles would add up to 180, so angle 1 and angle 2 would also be supplementary. Okay, we're now going to work some problems. It says using angle relationships to find angle measures. So we're going to be working some problems with different angle relationships. Number one, these two angles are an example of the vertical angles that we talked about before, because you have intersecting lines. These angles are across from each other, so therefore these two angle measures would be the exact same size. Angle X there would be 112 degrees as well. Let's go a step further and talk about, well, what about these two angles over here if we did need to find them? Since you have a straight line, two angles that are adjacent that form a straight line have to be supplementary. They have to add up to 180. So if we needed this angle over here next to it, since this is 112, we could take that away from 180 and we'd get 58. Also here, since these two form a straight line, that's 112. That would leave you with a 58-degree angle there as well. Or you could say those two are vertical, so they would have to be the same as well. Number two here, you have a 90-degree angle. Since this is a 68, we know the whole thing is 90, so those two angles here would have to add up to 90. So we simply take 90 minus 68, and that leaves us with a 22-degree angle there. Two angles that form a straight line are known as supplementary angles. So therefore, we know that these two angles would have to add up to 180 since they are supplementary. So take 124 from 180, and it leaves you with a 56-degree angle. Number four is very similar to number one. You have, first off, let's find angle X. Since you have a straight line, two angles that form a straight line have to add up to 180. So you simply take that 43, take it away from 180, which gives you a 137-degree angle. Now the rest of them are pretty easy. Since you have the two intersecting lines, you have lots of vertical angles here. So if this angle is 43, then that means that angle Y would have to be 43 as well. Since angle X is 137, that means that angle Z would also have to be 137 since all those angles are vertical. Number five. Notice your 90-degree angle here, which means that this line has to be perpendicular to this line, which means this is also a 90-degree angle. So that means that 72 degrees and angle Z here, these two angles would have to be complementary angles because they add up to 90. So 72, take it away from 90, leaves you with an 18-degree angle. The other two, I've got a straight line here. So that means that these two angles here would have to add up to 180 degrees. Since I have a 72 here, take that from 180, gives me a 108. And a couple of different ways to find Y now. Since this is a straight line, that means that these two add up to 180. So if you take 108 from 180, it gives you that 72, which is actually the same as this value here. The other way you could have done that is these two lines intersect to form vertical angles of 72 and 72. Number 6, angles 1 and 2 are vertical angles. And before we go any further, we can go back and look at our diagram. We know that if two angles are vertical angles, then they have to be congruent, the same size. If the measure of angle 2 is 105, then the measure of angle 1 would be the exact same thing, 105 degrees. Angles A and B are complementary. Before we go any further, if they're complementary angles, that means they have to add up to 90. Let me show you a trick here before I go any further that I could have showed you a while ago. But a way to remember complementary versus supplementary, think about this. Complementary are two angles that add up to 90 degrees. Notice that I can make that 90 out of that C. And supplementary means they add up to 180. So complementary, 90, supplementary, 180. So A and B are complementary. If the measure of angle A is 42, the measure of angle B, we simply, again, take that away from the 90. That would give us a 48-degree angle for angle B. P and Q are supplementary angles. If the measure of angle Q, okay, let's go back. Supplementary means that they're going to add up to 180 degrees. If Q is 64, then the measure of angle P, simply subtract that from 180 and you get 116 degrees. Angles 1 and 2 form a linear pair. Linear pairs, if you don't remember, they form a line. It's two angles that are adjacent, they're next to each other, that form a straight line. Since they form a straight line, they must also be supplementary. So that means there's going to be 180 total degrees. The measure of angle 1 is 113. Then the measure of angle 2, take that away, would be a 67-degree angle once you take that from 180. Okay, next up, we're going to use some algebra to do the exact same thing. We're going to have to know the same concepts we've been talking about. The measure of angle PQT, and let's figure out which angle that is. PQT would be this angle here. PQT is 3x plus 47 degrees. SQR, S to Q to R. SQR is this angle. And I want to point out that these two angles would be vertical angles, and vertical angles are always congruent. So therefore, the measure of angle PQT and the measure of angle SQR would have to be the same measure because they are vertical angles. Let's set these up. They're equal to each other. That's our relationship. Let's solve the relationship. Move 3x over by subtracting 3x. Move 25 over by adding 25. And we get 3x is equal to, I believe that's 72. Divide by 3. And you get that x is 24. But notice they don't ask you what the measure of x is. They ask you for the measure of angle SQR. So now everywhere we have an x, we can now plug back in a 24. So I'm going to plug it in both places just to check myself. 3 times 24 is 72. 72 and 47 is 119 degrees. 6 times 24 is 144 minus 25 is also 119 degrees, which makes us know that our answers have to be right because both of these angles are 119 degrees. Now let's see what we're looking for here. SQR, that's going to be 119. Next problem. Number 11, if AB is perpendicular to, that's that symbol. So that means that we have a 90-degree angle here and a 90-degree angle here. They're perpendicular lines. If DCE, which is this angle, is 7x plus 2, and ECB is that angle, we know that these two angles are complementary because they add up to 90. So therefore, my relationship here, I know that, let me erase that, it's a slip. I know that angle DCE, which is 7x plus 2, and angle ECB, which is x plus 8, they're not equal. A lot of people will make the mistake here of saying they're equal, but this is obviously a smaller angle. I know that they add up to 90, so what we're going to do is these two angles, when I add them, they will equal 90. There's your relationship that you're going to solve. Combine some like terms here. 7x and x gives me 8x. A positive 2 and a positive 8 would give me a plus 10. Bring down equals 90. I move my plus 10 by subtracting 10, gives me 8x is 80. So divide by 8, and that tells me that x is 10. So now everywhere I have an x, I can put a 10. 7 times 10 plus 2 would be a 72-degree angle. 10 plus 8 would be an 18-degree angle. So that tells me that this angle here is 18 or 72 degrees, and this angle is 18. So DCE is the one I'm looking for. That would be a 72-degree angle would be your answer. And number 12. The measure of KNM. Let's find KNM is this angle. MNJ is this angle down here. And we see there that those two angles form this straight line here. So therefore, those two angles form a linear pair. They add up to 180. They're supplementary. So angle KNM and angle MNJ. Those two angles, again, since they form this straight line, that means that when I add those two angles, I'll get 180. So there's your equation. Combine some like terms. I know that 8x and 4x gives me 12x. A negative 5 and a negative 19 would give me a negative 24. I moved my minus 24 by adding 24. So that gives me 12x is 204. Divide by 12. Let me type that in just to make sure. 204 divided by 12, enter. That means that x is 17. And again, notice that they don't ask me what x is. They say find the measure of KNM. And again, here's KNM, but again, I like to plug in it everywhere just to be certain. So since x is now 17, that gives me 8 times 17, which is 136, minus 5, which is 131 degrees. And I like to plug it in both places, like I said, just to check it. 4 times 17 here. 4 times 17 is 68, minus 19 is 49. And if you check that 131 and 49, when you add it together, it gives you that 180, which is what you're looking for, so that you know that you're right. Number 13. DEG, D to E to G is this angle over here. GEF, G to E to F is this angle up here. Is that. DEH, it tells me DEH, which is this one down here, is 9y plus 5. Now you got to be careful with this one because you got x's and y's mixed. So what I really don't want to mix x's and y's in an equation. So what I'm going to do is these two both contain the x's. So that's the ones I'm going to use first. And we know that those two angles form a straight line, so that means they're a linear pair. That means they add up to 180. So I know that my angle 5x minus 4 and 7x minus 8, when I add them together, I'm going to get 180. Combine like terms, 5x and 7x gives me 12x. A negative 4 and a negative 8 is a negative 12. To get rid of minus 12, we're going to add 12. Gives me 12x is 192. Since 12 is being multiplied by x, we're going to divide by 12. So that gives me that x has a value of 192 divided by 12. And that's 16. So everywhere I have an x, I can put a 16. 5 times 16 is 80, minus 4 is 76 degrees. So that means that this angle here is 76 degrees. 7 times 16 is 112, minus 8 is 104, which does check out. So this is a 104 degree angle. So let's put those numbers on here. Let me erase some stuff. So that tells me that this angle is a 76 degree angle, and this angle is a 104 degree angle. And if you remember, if this is a 76, then we know that this has to be a 76. If this is a 104, that means that this has to be a 104 because they're vertical angles. So what I can do now, I'm done with my x's. Nowhere in the problem do I have x's anymore. X is 16, so every x value can be replaced with the number 16. So what I'm going to do now, since DEH, let me do a different color here. Since DEH, which is this angle right here, is equal to 9y plus 5. What I can now say is 9y plus 5 has to equal 104 because this angle was equal to 104. So I can solve this equation to figure out what y is. To get rid of plus 5, we're going to do minus 5. I now have 9y is 99, so that gives me that y has a value of 11. And it told me to find the values of x and y, and there they are, 16 and 11. Number 14 says angle R and S are complementary angles. Anytime we see the word complementary again, we know that those two angles will add up to 90 degrees. If the measure of angle R is this and S is this, again, there's your two angles, 12x minus 3 and 7x minus 2. We know that when I add them together, I'm going to get 90. Combine like terms, that's a total of 19x. A minus 3 and a minus 2, you can use your calculator as a minus 5. Solve the equation to get rid of minus 5. I do plus 5. Leaves me with 19x is 95. Since 19 is being multiplied by x, we're going to divide by 19, which gives me x is 5. But again, it says find the measure of angle R. So instead of just leaving it at that, make sure that you plug in that x. Angle R is 12 times 5, which is 60, minus 3, which is a 57-degree angle. And you can plug it into the other one to check it if you like. Number 15, it says P and Q are supplementary angles. Again, supplementary is going to mean they're going to add up to 180 degrees. Here's P. Here's Q. Whoops. Jumped on me. So Q was 9x minus 3. Since they're supplementary, that means when I add the two angles, it's going to equal 180. There's your relationship. Combine your x's. It's a total of 13 x's. A positive 1 and a negative 3 on your calculator is a negative 2. So I put all my like terms together. Get rid of minus 2 by adding 2. That's going to be 13x is 182. Since 13 is being multiplied, we're going to divide by it. So I'm going to do 182 divided by 13, which gives me a value of x is 14. But again, always look and see what you're asked to solve for. We're looking for the measure of angle Q. So therefore, you're going to take that 14 and plug it in. 9 times 14 is 126 minus 3 is 123 degrees when you plug that 14 in for x. Hey, now we're getting into some little bit more difficult problems. It says angle 1 and angle 2 form a linear pair. Before we go any further, we know that since they're a linear pair, that's a straight line, means they're supplementary, so they're going to add up to 180 degrees. So there's your relationship. The measure of angle 2 is 6 more than twice the measure of angle 1. So here's what I'm going to do. I'm going to say the measure of angle 1 and the measure of angle 2, and I'm going to draw me a little chart here just to keep things straight. The measure of angle 2 is 6 more than twice the measure of angle 1. Well, it looks like everything's based on the measure of angle 1 here. It's giving me how big angle 2 is based on angle 1. So what I'm going to do is I'm going to let angle 1 be an x value. I don't know how big it is. X's are used, again, to indicate unknowns. I don't know how big angle 1 is, so let it be x. But I do know this, that angle 2 is 6 more than twice the measure of angle 1. Well, first off, twice, I like to work these backwards. Twice the measure of angle 1 would be twice times the measure of angle 1, which was x. However, now I need to do 6 more than that. And think of it as if somebody else has $6 more than you do. You're going to take the amount of money that you have and you're just going to simply add 6 to it. So therefore, the measure of angle 2, if angle 1 is x, then angle 2 will be 6 more than double x, or 6 more than twice x. So there's your two measures. Now we need an equation. These are expressions because there's no equal signs here. We need to have some sort of relationship between the two, and here it is. We know that angle 1 and angle 2 form a linear pair. We know that if I were to take angle 1 and angle 2, that their values would add up to 180. So that's what you do. Here's angle 1, here's angle 2. Put them together, they're going to add up to 180. Combine like terms now, just like the previous problems. X and 2x gives you 3x plus 6 is 180. Get rid of plus 6 by minusing 6. Gives you 3x is 174. Divide by 3 gives you x is 58. So therefore, look what x represents now. X is the measure of angle 1. So that means that angle 1 is 58 degrees. Angle 2, now that we know that x is 58, 2 times 58 is 116 plus 6 is 122 degrees. And you can check that. Angle 1 is 58. Angle 2 is 122. It says find the measure of angle 2, so there would be your right answer. Number 17 says J and K are complementary. We'll go any further. We know they add up to 90. That's what complementary means. The measure of angle J is 18 less than the measure of angle K. So here we go. We got angle K here. I'm going to do me another little chart. And angle J. Angle J is 18 less than K, so therefore we're going to let everything's based on K because it gives us how big J is based on K. J is 18 less than that, so angle J would be that value minus 18, 18 less than it. So there's our two angles, our x values for our two angles. We know that the two angles are complementary, so now we can take those two angles. And since they're complementary, we know that when I add them together, it's going to give me a total of 90 degrees. Same thing now, combine like terms. Move the minus 18 by adding 18. Gives me 2x is 108. Divide by 2 gives me x is 54. So since I now know what x is, that means that this angle is a 54-degree angle. This would be a 54 minus 18 or a 36-degree angle, and you can check that those two would be complementary. So find the measure of each angle. We've done that. Number 18, UW bisects. Again, that word again, bisects means to cut in half. That means that this angle would therefore have to be the same size as this angle. They're equal to each other. TUW, excuse me. TUW, which is this angle, T to U to W, that would be that angle. It's 13x minus 5. WUV would be that angle. It's 7x plus 31. So therefore we can now say that since this angle and this angle, since that UW bisects it, those two angles are the same size. So that means that 13x minus 5 and 7x plus 31 would have to be equal to each other. No like terms on either side, so let's move 7x by subtracting 7x's. Let's move minus 5 by adding 5. That gives me 6x's equals 36. Divide by 6 gives you x is 6. And since x is 6, we plug it back in. 13 times 6 is 78 minus 5, which would be a 73-degree angle. And 7 times 6 is 42. 42 and 31 gives you another 73-degree angles. And we know that since those two values are equal, that we must be correct. So find the value of x, and x would be 6. Okay, a couple more problems here. If MO right here bisects, again, it means cuts it in half. It bisects this angle, so that means these two small angles right here have to be the same size. PMN, that's this whole angle here. PMN is a 74-degree angle. Now what I'm going to do is, since that's 74 and this bisects it, I'm going to cut that in half, and that means that each of these smaller angles would have to be 37-degree angles. That's 74 cut in half. OMN, which is this angle right here, it says it's 2x plus 7, but we just found out that it's also equal to 37. Since OMN is 2x plus 7, and we know that that OMN is also 37, we can say those two values are the same. They're equal. Move plus 7 by subtracting 7. Gives me 2x is 30. Divide by 2 gives me x is 15. And that's the value that you're looking for. Okay, last problem. If EF, again, bisects CEB, which means that this angle and this angle are the same size. It says that CEF, which is C to E to F, which is right here, is that size. FEB is that size. We know that those two angles we just said was equal, so that means that 7x plus 21 has to be the same as 10x minus 3. No like terms on either side. Move 7x by subtracting it. Move minus 3 by adding it. Always do the opposite. It gives me 3x is 24, so x must be 8. We can plug those back in, and it's the same process over and over. 7 times 8 is 56 plus 21. 56 and 21 is 77. So that means that this is a 77-degree angle. You can plug it in over here, and you'll get 77 as well. Now let's see if we answered what they asked us to. What is the measure of angle DEB? Which is actually this angle. So we've got, this is a 77-degree angle. This is a 77. But I want to point out that you actually have a straight line there, and that's how we're going to figure out what DEB is equal to. If this is 77 and this is 77, that adds up to 154 total for these two angles. The three have to add up to 180 because they form a straight line. Take the 154 away from 180, and you're going to get the leftover DEB angle is a 26-degree angle.